All right, let's get right into it. Think about all the smart devices around us. They're constantly collecting data, just streams of numbers, right? But how do we get an AI to look at that raw data and actually, well, understand it, to see the meaning behind the numbers? That's the puzzle we're going to solve today. I mean, just imagine this for a minute. What if your smart home didn't just silently crank up the AC, but could actually tell you, hey, I'm turning on the cooling because the sensor says it's getting hot, and I see motion, so I know you're home. That's the kind of intelligence, that massive leap, we're talking about. But to get to that really cool future, we first have to tackle a huge challenge in AI. It's something people call the black box problem. You see, we have these incredibly powerful AI systems that are amazing at doing things, but they have no idea how to tell us why they're doing them. And here's what that looks like. On one hand, you have traditional systems. They take in a fire hose of numbers, technical term is numeric vectors, and they spit out another set of numbers that tells a machine what to do. Super efficient for sure, but we can't really peek inside and see the logic. But then you have this new world opening up with large language models, where the whole goal is understanding, explaining, and even reasoning. So how do we get from one side to the other? How do we bridge that gap? Well, the really elegant idea here is to use an LLM as a kind of translator. It acts as a semantic bridge that can take all those raw, meaningless numbers and turn them into something we can actually understand. So the way this works is you have the LLM basically sitting on top of the traditional system, acting as the brain of the operation. It's the component that translates the low-level sensor data. It's the part that gives us those human-readable explanations we wanted. And it can even offer recommendations. It's the reasoning and planning layer that was missing before. Okay, but for an LLM to do all this magic, we have to teach it a brand new language, right? Because LLMs are trained on, books and the internet. They don't come out of the box understanding temperature readings or motion detector signals. We have to teach them the language of sensors. And the absolute key to this new language is a concept called tokens. You have to get this. An LLM doesn't really see words or numbers. Everything, and I mean everything, gets converted into these tokens, which are just integers. Think of them as the ABCs of the AI's world. They are the absolute rock-bottom building blocks of its understanding. And this workflow makes it super clear how it all happens. First up, you've got the raw sensor data, just plain old numbers. Then that gets converted into a simple sentence like, temperature is high. And finally, that sentence gets chopped up into those integer tokens that the model can actually work with. Now, here is a really, really critical rule you cannot break. The tool that creates the tokens, the tokenizer, and the AI model itself have to be a perfect match. They have to come from the exact same training session. Why? Because the tokenizer has the specific dictionary that the model knows. Using a mismatch would be like trying to read a book in French using a German dictionary. You just get total nonsense. Okay, so now we get how the data gets into the model in a language it understands. But how does the model learn what to actually do with that information? Well, like with all AI, it comes down to the data you train it on. And this, right here, is the real aha moment. It's actually pretty simple. You train the model on thousands of these input-output pairs. The input is just a plain text description of what the sensors are seeing. Temperature is high, motion detected, and the output is the exact action or explanation you want it to generate. Activate cooling system and log activity. After seeing enough examples, the LLM just learns the pattern. It's that powerful. Now, when you start putting all these different pieces together, you realize you're not just building a slightly smarter gadget, you are actually laying the foundation for something so much bigger, a whole new class of AI that can genuinely reason and plan. And that's what we call Agentic AI. We're talking about systems that don't just react to what's happening right now. They can understand the context, they can create complex, multi-step plans, and they can take actions all on their own to achieve a goal. This whole method of teaching an AI to understand the language of sensors, it's a fundamental step to making those truly intelligent agents a reality. So all of this leaves us with a really fascinating question to think about, doesn't it? We've just walked through how to teach an AI to speak the language of the physical world through its sensors. So what's next? What's the next language we can teach it? The language of the stock market? The language of biology? The possibilities are just absolutely wide open.